Hi, it's Dr. C. This short post is to discuss vector addition and subtraction. Okay, first of all, let's just briefly review what we mean by a vector. A vector is a quantity that has a size and a direction. Okay, briefly, what do we mean by the word size? A size is a value. Sometimes the word size is changed, so it will make it a little bit more technical sounding. We use the word magnitude. So very often we say a vector is a quantity that has a magnitude and a direction. Now we draw a vector as an arrow. The arrow has a length, which is equivalent to the size or the magnitude of the vector, and the direction, normally referred to in physics by theta, is the direction indicated by an angle to the x-axis. Doesn't have to be to the x-axis, but that's the typical angle that we talk about. And with respect to angles, the x-axis is generally our base, and if we go anti-clockwise, we talk about an angle that's positive, and if we go clockwise, we talk about an angle that's negative. Now, if you can't remember about vector components, Vx and Vy, then you need to look at one of the other videos on the channel. But for memory, Vx, the x component of V, is V cos theta, and Vy is V sin theta. These two equations basically come from what we call SOHCAHTOA. So now let's look at the idea of vector addition. We're going to write down two vectors, draw them as arrows. The head of the vector is at the arrow head. The tail of the vector is at the other end. And we have here an x-axis, a y-axis, and vector number 1 has a size of 10 in whatever units we're talking about, and it has an angle of 20 degrees to the horizontal. Vector number 2 has a size of 18 and an angle of 40 degrees. And what we're going to do is add them. V total is equal to V1 plus V2. Now, for those that can't remember how we add vectors, what we do is we draw our two vectors and we put them head to tail, head to tail. So let's move V2 and place its tail at the head of V1 like that. And the resultant vector is from the beginning of the first one to the end of the last one. Now, if I zoom in on this, we can see that the x component of V1 is that length there. And the x component of V2 is that length there. And the x component of the resultant, the x component of V tot, is that distance there. So it is very clear to see that if you're trying to work out the total vector, then by adding up the x components of the two vectors, we get the x component of the total vector. In other words, this plus this equal this. And it's the same for the y components. That distance plus that distance equals that distance. So this is the way we add vectors. We work out the x component and the y component of the two vectors. We add up the two x components to get the total x. We add up the two y components to get the total y. So let's look at that in practice for the two vectors that we drew earlier. Okay, for vector number 1, the x component will be given by v1x is v1 cos theta, which is 10 cos 20, which is 9.4. The y component will be v1 sin theta, which is 10 sin 20, which is 3.4. Okay, we do the same for v2. The x component is v2 cos theta, which is 18 cos 40, that's 13.8. I'm expressing my answers to the first decimal place. And the y component is v2 sin theta, which is 18 sin 40, which is 11.6. Now the total of these two is given by total x component will be the x component for v1 and the x component for v2 added together. So that will be 9.4 plus 13.8, and 9.4 plus 13.8 is 23.2. And the total vector along the y direction is going to be the y component of the one plus the y component of the other, which is 3.4 plus 11.6, which is 15.0. So these are the two components. You can almost consider them as x and y coordinates for a point. If you drew an x and a y axis and you were told to plot a point which had an x value of 23.2 and a y value of 15.0, then you would draw a point there. That is the arrowhead for the total vector. And it allows us to easily see from the right angle triangle that we have here that by Pythagoras, that squared plus that squared is equal to the square of the hypotenuse. And from SOHCAHTOA, if that's theta, it tells me that tan theta is the opposite over the adjacent. In other words, 15 over 20.3. So the only maths that we're using in all of this, beyond simple addition, is Pythagoras and SOHCAHTOA. So let's go back and finish the calculation. Okay, so we have our x and our y axes. We've got our total vector, the addition of v1 and v2. We've got an x component of 23.2, a y component of 15.0, an angle theta. So we can say the total vector's size is 23.2 squared plus 15 squared square rooted. That's 27.6. And the tan of theta is the opposite over the adjacent. That's what we're calling the vector y component over the vector x component. That gives theta as tan to the minus 1 of vy over vx. Putting in the numbers, tan to the minus 1 of 15.0 over 23.2 gives us 32.9. Okay, now that we've got that basic idea sorted and we've gone through an example, let's look at subtracting vectors. Now, vector subtraction is slightly more complex than vector addition, but not very much. The important thing to realize is that if we're subtracting vectors, it does depend which one we're subtracting from which. For example, if I have two numbers, 3 and 5, then 3 minus 5 is minus 2. However, 5 minus 3 is 2. So when we talk about subtracting vectors, we must make sure we get the vectors the right way around. Are we talking about v1 minus v2, or are we talking about v2 minus v1? That's a simple point, I know. We also need to realize that subtracting vectors is the same as adding a negative vector. Now, to make sure we understand that, because this is the crucial point, the total vector in our particular example is going to be v1 minus v2, and we need to realize that that's the same as v1 plus minus v2. Those two things are equal. So now we've created, rather than a subtraction of two vectors, an addition of two vectors, but one of them is negative, which means it's very important to understand how to get minus a vector. Let's just briefly draw x and y axes. Imagine I have a vector v, then the minus vector has the same size, but it has the opposite direction. This is minus v. Now, if you look carefully at what we've done here, for the vector v, this was the x value, and this was the y value. If you look at minus v, this is its x value, this is its y value. This is minus this value, and this is minus this value. So to take any vector and work out what the negative vector is, you just look at the x and the y components and change the sign of them. If the x component is plus 5, then the minus vector, the negative vector, will be minus 5. Okay, so we've already got the vector components worked out, so let's look at that. Minus v2x is minus 13.8, and minus v2y is minus 11.6. We just take the x value and the y value and change the sign. I have v1 and I have minus v2. I'm going to add them together because v1 minus v2 is v1 plus minus v2. So v total x 9.4 plus minus 13.8, which is minus 4.4, and v total y 3.4 plus minus 11.6, which is minus 8.2. So we now have the components for the resultant vector. So a quick sketch on an xy is minus 4.4 minus 8.2. So that is v tot. The angle is that about the x-axis. So we can say that v tot 4.4 squared plus 8.2 squared square rooted, which is 9.3. And the angle is found by considering this right-angled triangle and working out this angle and adding 90 to it. So using SOHCAHTOA, tan of this small angle, I'll call it phi, tan of phi minus 4.4 divided by minus 8.2. So phi is 10 to the minus 1, 4.4 over 8.2. So phi is 28.2. Therefore, theta is 28.2 plus 90, 118.2. And we should remember that it's actually below the x-axis, so that should be minus 118.2. Now, does this make sense with respect to the idea that we could graphically sketch this? Here we see the original two vectors v1 and v2. There's minus v2. Head to tail gives a resultant from the beginning of the first to the end of the last. And that is the angle, which we kind of have here. And it's kind of pointing downwards. I don't have a scaling on here, so it's a little bit difficult to check that the height is correct or the length is correct. But it seems reasonable. And there you have it, subtraction of vectors. I hope that makes sense. I know that the video is a little bit longer than we might have liked, but I think it is a very important skill in physics to be able to add and subtract vectors, not just graphically, but numerically. And this is something we need to practice, we need to become comfortable with, because it's crucially important. Take care, stay safe, have a good one.